So here's another system of equations. We have x plus y equals 4. Let's look at that one first because we're going to look at each one of these systems in a very similar way. So x plus y equals 4. Well, here's the x and y axes. So imagine we were looking down. This is supposed to be an eyeball. Looking down like this onto the xy plane. What would this right here would just be the graph. X plus y equals 4 would just be the graph of a line. So let me take away that eyeball because it's kind of creepy. What would that x plus y equal 4 graph look like? It would look like a line right through. This is supposed to both go through x equals 4 and y equals 4, and I did doing a terrible job of this. Here we go. Right, so there's the line. But this is in fact, when we include the z variable, this in fact is a plane. You can think of this, here we go, if z equals whatever this number is, 10, it would be this plane that kind of cuts through our cube. But these are all of the x's, y's, and z's that satisfy x plus y is equal to 4. Okay, what about this line? Z plus y equals 6. You can see x is not in this equation. And now if we took our eyeball over here, put our eyeball over here, let's see, and we were looking, this way, you can see we'd be staring at this zy plane. And just like we did a second ago, if z plus y equals 6, it's going to, the line that's going to be down here would go through these 2 points. I would just remember we're looking down at this zy plane, and this is it looks like standard form. It isn't standard form, but with z and y. And how would that line look? It would look. Let's see if I can do it right this time. It would look like this. And you know, x sort of doesn't matter, if you will. X can be anything, but you can see this other line on this on this x equals, let's say this is x equals 7 plane. It would be we'd have this line, and then you could see the extension. It would be this kind of this plate. Now, where would this first plane and the second plane intersect? They would intersect at a line, and you can kind of see the coordinates of the line here. This would be where this line intersects this plane, and this line intersects this plane right here. So hopefully you can see this. I'll do it in green. This would be the intersection of these 2 planes. And let me draw it so you can, because it would really go like this, and then it would go behind this line here. But it would go out to infinity. So I go back that way, and go back way. Now that's just the intersection of these 2 planes. So what's the next thing? Well, we have this other plane. 2x plus 4z is equal to 8. Okay, so how are we going to look at that? Now we're going to put our eyeball right out here, floating in space, kind of where you are looking at this, and you look at your zx plane, and this is standard form right here. Again, z is when x is equal to 0. So we're on, here's the x-axis, right? When we're right here, when x is equal to 0, z is equal to 2. So this is way back there behind both of these planes. And let's see, when z is equal to 0, so again we're on this axis, we're on the x-axis. X is equal to 4, so it goes right there. So this line is way back behind these other planes. This to connect these 2 dots is way back beyond these other 2, but hopefully you can see it kind of extending way back there. It's a terrible line, but and meeting up with its, that wasn't meant to be drawn that way, that should have been solid. Meeting up with this line, and so it will be the plane that is defined by this. Well, this plane is going to cut through this green line, right? This green line is going back and through right over here, and you can somewhere there's going to be an intersection, and that x, y, and z is going to be what satisfies all three of these equations. And how would we find that exactly? Through elimination. Okay, if x plus y, x plus y is 4 and x plus y is equal to 6, then it must be true that if we subtract these two, take the top equation and subtract off the bottom equation, we get the y's will disappear, but we have x minus z is equal to minus 2. And then we can do elimination again. Let's do twice the bottom, taken away from the top. 2x minus 2x is 0. 4z plus 2z is 6z. 8 plus 4 is equal to 12. So we have our z coordinate. And I should probably do that in red, right? Z is equal to 2. What is x equal to? If z is equal to 2, just look at this equation. Y has to equal 4. Right? Because 2 plus some number is equal to 6, that number has to be equal to 4. If y is equal to 4, x must be equal to 0. X equals 0. So there we have our intersection of these three planes. That point right there is, whoops, we should write them in an ordered pair. It's just like an ordered pair. This is a triplet. It should be x, y, z, 0, 4, 2. Okay. I might get cut off here, but we should think about this in terms of a matrix also. Remember, we have these three equations right here. These three equations. And how would we write this in a matrix? We have x plus y, and I'm going to leave a space because it's really plus 0z is equal to 4. And we have, there's no x in this next equation, we have y plus z is equal to 6. And 2x plus 4z, so 2x plus 4z is equal to 8. And this we could write as a matrix equation and use our calculator, and you can confirm that the inverse of the coefficient matrix is going to be 1, 1, 0, 1, 0, 1, 1, 2, 0, 4. The inverse of that matrix times this 4, 6, 8 is going to be this point right here. Okay.